Have you ever wondered how we actually know that something we do today could impact our health, like way down the road? It's a huge question in science. Well, today, we're going to pull back the curtain on one of the coolest tools scientists have to peek into the future of our health. Let's get into it. It all starts with a number. Just look at this, 1.61. Kind of random, right? On its own, it means nothing. But in the world of public health, this number tells a really important story. And that story is this. It's the increased risk smokers have for developing coronary heart disease compared to people who don't smoke. It's a fact most of us have heard a million times, right? It's a classic public health warning. But that leads to a really good question. How did scientists figure that out? It's not like you can do a quick lab test for something that takes decades to develop. So how do they connect the dots over all that time? Let's solve this little mystery. Well, the answer lies in a special kind of scientific game plan, a sort of blueprint that lets researchers track health over a really, really long time. It's called a cohort study, and a cohort is really just a fancy word for a group of people who have something in common. In these studies, scientists follow these groups for years, sometimes their whole lives, to see how an exposure, something like smoking or a particular diet, affects an outcome, like getting a specific disease. The key thing is, it's all about looking forward. They start today and just watch to see what happens. And the way they do it is actually pretty simple and logical. Step 1, you find two groups of people who are totally free of the disease you're interested in. One group has the exposure, are smokers, and the other doesn't. Step 2, you just follow them for years. You don't do anything, you just observe. And finally, step 3, after all that time, you count up who got sick in each group and you compare the numbers. That's it. Okay, so that's the theory. But what does this look like in the real world? Let's take that blueprint and apply it directly to our smoking and heart disease example. So, here's where it all begins. You've got your two groups. On one side, 3,000 smokers. On the other, 5,000 non-smokers. But here's the absolute most important rule of the whole thing. At the very start, nobody in either group has heart disease. It's a clean slate. You have to start that way so you're only tracking new cases. And then the waiting game begins. This is where the patience comes in. For years, maybe even decades, researchers just follow these folks. They check in, they track their health, but they don't interfere. They are just patiently watching and recording who, over all that time, ends up developing heart disease. This part, this long-term follow-up, is the absolute heart and soul of a cohort study. All right, so let's fast forward. The years have passed, the data's been collected. Now for the fun part, turning all of that observation into a single number that actually tells us something about risk. So here are the results from our imaginary study. You can see 84 of the smokers got heart disease. And in the non-smoker group, 87 got it. Now wait a minute, you might be thinking, 87 is more than 84. But remember, the groups were totally different sizes to begin with. Exactly. So to make a fair comparison, we can't just look at the raw numbers. We need to figure out the rate of new cases in each group. It's called the incidence, and it lets us compare them apples to apples. So for the smokers, we take those 84 cases and divide by the 3,000 people in the group, and that gives us a rate of 28 new cases for every 1,000 people over the time of the study. Okay, hold that number. Now for the non-smokers, we take their 87 cases and divide it by their 5,000 people. And their rate is 17.4 new cases per 1,000 people. Okay, now you can really see the difference, right? And really, the whole point of this entire exercise is what this quote says. We're trying to see if there's an excess risk for the group that was exposed. Is their risk truly higher than what you'd see in the general unexposed population? The way we do that, the way we nail down that excess risk into one solid number, is by calculating something called the relative risk. This is the big payoff. And this is where it all comes together. We just divide the rate in the exposed group, that was 28, by the rate in the unexposed group, 17.4, and what do you get? 1.61. Bam! The number from the very beginning. We've cracked it. It means the smokers in the study were 1.61 times more likely to get heart disease. How cool is that? So, now that we know how they work, let's talk about the so what. Why are these studies so incredibly important for all of us? Well, like any tool, they have their pros and cons. The biggest pro?
They prove the exposure came before the disease, which is huge for suggesting something is a cause. They're also great for studying rare things people are exposed to. On the flip side, they are crazy expensive and take forever, and there's always the danger people will just drop out over the years, which can mess up the results.
But make no mistake, these studies have changed the world. Think about the legendary Framingham Heart Study. It started way back in 1948, following people in one town in Massachusetts, and it's still going. It's because of that single study that we learned about the major risk factors for heart disease, like high blood pressure and cholesterol. It's a true cornerstone of modern medicine.
So when you boil it all down, here's the takeaway. Cohort studies are our best window into the future. They let us patiently, carefully watch how our world and our choices affect our health over a lifetime. Not in a lab, but out here in the real world. Which leaves us with a really fun question to think about. With all the new things in our world, from microplastics in our water to new technologies we use every day, what big health mystery do you think the next great, decades-long cohort study is going to solve for us? Thanks so much for watching.